inverse x plus cos inverse x, number 1. Number 2, tan inverse x plus cot inverse x. Number 3, secant inverse x plus cosecant inverse x. So that is equal to, so in all cases it is pi by 2, it is also pi by 2, it is also pi by 2. Observe, sin, cos, tan, cot, secant, cosecant, just like that. So it is true for all. Sin inverse, actually you see there, sin inverse x, cos inverse x, domain same, closed interval of -1, 1. Next tan inverse x, cot inverse x, domain same, capital R. Next secant inverse x and cosecant inverse x, the domain is same, capital R minus open interval of -1, 1. Means you come here. So sin inverse x plus cos inverse x equal to pi by 2 for all x belongs to its domain, closed interval of -1, 1. Next its domain for all x belongs to capital R. So for all its domain x belongs to capital R minus open interval of -1, 1. Next number 6. Here one simple formula, tan inverse x minus tan inverse y. It is true in all cases as tan inverse of x minus y divided by 1 plus xy. Now very most important formula, tan inverse of x plus tan inverse of y. Here two main cases are there. Here tan inverse x plus tan inverse y is equal to, here for case 1 is what? X positive and y positive. This is case 1. Next it is case 2. X negative and y negative. Both are positive case, both are negative case. Here tan inverse of tan inverse, it is very important formula, tan inverse x plus tan inverse y equal to, in this case it is tan inverse of x plus y divided by 1 minus xy if xy is less than 1. Means what? X you read as x positive, y positive and xy less than 1. Then tan inverse x plus tan inverse y equal to tan inverse of x plus y divided by 1 minus xy. Next here same question, tan inverse x plus tan inverse y is equal to, same formula, it is tan inverse of x plus y divided by 1 minus xy in the case of xy is less than 1. So here also read as x negative and y negative, and if xy less than 1, then tan inverse of x plus tan inverse y equal to tan inverse of x plus y divided by 1 minus xy. Later second case, xy is greater than 1. xy is greater than 1. Its formula is same. First you copy the same. Tan inverse of I will write the full form. So that is equal to tan inverse of x plus y divided by 1 minus xy plus pi. If xy is greater than 1. Here same case, if xy is greater than 1, here tan inverse of, first copy the same, x plus y divided by 1 minus xy, here plus pi, just you write minus pi. It is easy remembrance. Next, last case, if xy is equals to 1, if xy, if xy is equal to 1, its value is plus pi by 2, here minus pi by 2. If xy is equal to 1, so therefore first x positive, y positive, 3 cases, x negative, y negative, 3 cases. So it is easy to remember plus pi by 2, it is minus pi by 2. First case is same. In second case, it is greater than 1, that's plus pi, right, plus pi, it is minus pi. Next, another formula, important formula, here, Roman number 8. Let x comma y comma z have the same sign. This is the main condition. Have the same sign, and the condition xy plus yz plus zx is less than 1. Then tan inverse x plus tan inverse y plus tan inverse z is equal to tan inverse of x plus y plus z minus product xy z divided by 1 minus bracket begin xy plus yz plus zx. So that is equal to pi by 2 if xy plus yz plus zx equal to 1. In the sense of this is equals to 1, then 1 minus 1 equal to 0. Denominator 0 means this is infinity. Tan inverse of infinity is pi by 2. Why? Tan pi by 2, tan 90 degrees means tan pi by 2 equal to infinity. Then pi by 2 is equal to tan inverse of, we can write like that. According to this, we are writing pi by 2. Some important properties. Roman number 1. First, sin inverse of minus x is what? Sin inverse of minus x equal to this minus sin inverse x. For all, x means domain of sin inverse x belongs to. You come here. Sin inverse of domain is what? Closed interval of minus 1 comma 1. Here we are writing the same closed interval of minus 1 comma 1. So therefore, if we by heart this table, then you need not by heart here also. Okay. So therefore, we are writing the values of x means the domains of respective functions. Okay. Next, cosecant inverse of minus x is also in the same pattern. Cosecant inverse x, it is for all x belongs to. What is cosecant inverse of domain? R minus, R, capital R minus, open interval of minus 1 comma 1. This is number 1, this is number 2. Next, number 3, tan inverse of minus x is also minus tan inverse x for all x belongs to. X means domain of tan inverse. You see there, domain of tan inverse means R. X belongs to capital R. Next, fourth one, it is different. Cos inverse of minus x. Next, number 5, cot inverse of minus x. Next, number 6, secant inverse of minus x. So this is pi minus cos inverse x. It is also pi minus cot inverse of x. It is also pi minus secant inverse of x. It is for all x belongs to the domain of cos inverse of x is closed, you see there, closed interval of -1 comma 1. Next, domain of cot inverse of x means R. For all x belongs to capital R. Here domain of secant inverse is R minus open interval. So for all x belongs to capital R minus open interval of -1 comma 1. So therefore it is the domain of respective functions. These three are having the same pattern. These three are having the same pattern, just like pi minus pi minus pi minus. It is just minus minus minus. So you can easily remember all these 6 formulae. Next, number 1, Roman number 2. Sine inverse of x can be, what is its reciprocal? Sine reciprocal cosecant. Okay, inverse same. We are writing its reciprocal 1 by x. Okay, sine inverse. What is sine inverse domain? You see there, closed interval of -1 comma 1. Okay, you come here. So this is for all in the domain of the sine inverse means closed interval of -1 comma 1. But in the denominator x is there. That's why x should not be 0 for no loss of generality. Okay, this is number 1. Next, number 2, same. Cos inverse of, okay, 1 minute. Similarly, cosecant also. Cosecant inverse of x can be cosecant reciprocal sine. So sine inverse of x reciprocal 1 by x. We are writing on RHS side reciprocals. Next, for all x belongs to, you come to LHS, cosecant inverse x. You go there. Cosecant inverse x domain is what? Capital R minus open interval of -1 comma 1. So capital R minus open interval of -1 comma 1. Here in the denominator x is there. So x should not be equal to 0. Okay, it is included. 0 is deleted here, like that. 0 is in this interval. Already it is deleted. Okay, next number 3. Next, cos inverse of x is equal to cos reciprocal secant. Okay, x reciprocal 1 by x. So for all x belongs to, what is the domain of cos inverse? Closed interval of -1 comma 1. Of course 0 should be deleted because in the denominator 0 is there. Next, 4th one, secant inverse of x equal to, what is reciprocal of secant? Cos, like that. What is reciprocal of x? 1 by x. For all x belongs to, what is the domain of secant inverse x? R minus open interval of -1 comma 1. Okay, x should not be equal to 0. Already it is deleted. Next, number 5. So sine, cosecant, next tan inverse of x is equal to, what is reciprocal of tan? Cot inverse. So it is cot inverse x, comma x means here x means, what is the reciprocal of x? 1 by x. For all x, what is the domain of tan inverse x? Capital R. But here some special condition is there. It is true for positive real number. Next, another case is there. For all x negative. Negative means you copy as usually cot inverse of 1 by x minus pi. Okay, next, in this Roman number 2, number 6 is what? Cot inverse of x equal to, same, tan inverse of 1 by x. It is for x is positive. Next, understand. Next, if x is negative, actually here we wrote minus, So it can be tan inverse of 1 by x opposite sign plus pi plus pi. Okay, this is cot inverse x. So sin inverse, cos inverse, tan inverse, cot inverse, secant inverse, cosecant inverse. So we are observing the domains of LHS functions. Over. This is over. Next, Roman number 3, third kind formulae. Here, sin inverse of sin theta, sin inverse of sin theta, number 1. Number 2, cos inverse of cos theta. Number 3, tan inverse of tan theta. Number 4, cot inverse of cot theta. Number 5, secant inverse of secant theta. Number 6, cosecant inverse of cosecant theta. So here it is theta, it is also 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 theta. But we have to write the area of theta. It is main important point. Here for all theta that belongs to here sine is inverse in which area? Closed interval of closed bijective area. We have to write the bijective area. The bijective area means what? You come here. Indirectly we are writing ranges. Okay, cos inverse of cos theta is equal to theta. I am asking one simple question. Where cos is bijective for all theta that belongs to closed interval of 0, pi. Already you come here. Already I said here cos in this area. It is bijective. Similarly, tan bijective for all theta belongs to open interval of minus pi by 2, plus pi by 2. Next, for all theta that belongs to open interval of 0, pi. Cot theta. Here you come here. Cot theta bijective in open interval of 0, pi. Next, for all theta that belongs to what is that area? Closed interval of 0, pi minus the set of pi by 2. Here it is for all theta that belongs to closed interval of minus pi by 2, pi by plus pi by 2 minus the set of 0. Indirectly we are copying only the set of ranges. So you need not remember separately. Just you by heart ranges, theta values like that. Okay, this is Roman number 3. Type of formulae. Number 1. Number 1, sin of sin inverse x. Number 2, cos of cos inverse x. Number 3, tan of tan inverse x. Number 4, cot of cot inverse x. Number 5, secant of secant inverse x. Number 6, cosecant of cosecant inverse of x. Actually it is x, it is also x, it is the simple formula. Okay, but the matter is about x. X is what? Here you come here, sin inverse of sin theta. Theta means we wrote the ranges of sin inverse x, because already I said if sin inverse of x is equal to theta, then y implies x equal to sin theta, whereas x belongs to closed interval of minus 1, 1 and theta must belongs to closed interval of minus pi by 2, plus pi by 2. I said the same. So similarly I said in cos inverse, tan inverse, cot inverse, secant inverse, cosecant inverse. So we have here in Roman number 3 we have to write the limitations of theta. Therefore, you by heart both x value and theta value. Here we need theta value. That's why theta means ranges. Here we need x value means domains. You come here. So x sine inverse. So for this is true for all x belongs to what is the domain of sine inverse x? Closed interval of minus 1 comma 1. Here what is the domain of cos inverse x? Same closed interval of minus 1 comma 1. What is the domain of tan inverse x? Here capital R for all x belongs to capital R. Next, what is the domain of cot inverse x? Capital R for all x belongs to capital R. What is the domain of secant inverse x? Capital R for all x belongs to capital R minus open interval of minus 1 comma 1. Next, for all x belongs to cosecant inverse. So capital R, capital equations. Find the principal values of the following functions, namely sin inverse of minus 1 by 2, cosecant inverse of minus root 2, cos inverse of minus 1 by 2. First, we recall sin inverse of it is in the form of minus something x, that is equal to minus sin inverse x. Until this topic is over, we first think of the value of x, means limitations of x, means domain of x. Actually, it is true that for all x belongs to closed interval of minus 1 comma plus 1. So, before using this formula, we have to verify the values of x, whether it is in this area or not. Okay, compare with this. Here x equal to, here x is equal to just 1 by 2. So therefore, it is belongs to closed interval of minus 1 comma 1. Means what? This is the real number or real line. This is plus 1. This is minus 1. Where is 1 by 2? Here is 1 by 2. So therefore, definitely this 1 by 2 lies in closed interval of minus 1 comma plus 1. So we are permitted to use this formula. So therefore, sin inverse of minus 1 by 2, that is equal to, applying this formula, minus sin inverse of 1 by 2. So that is equal to minus, here look at the board, minus sin inverse of 1 by 2. Actually, in principal table, sin 30 degrees equal to 1 by 2. So it is in the form of sin theta, that is equal to x. In the definition, we said x equal to sin theta, that by implies theta equal to sin inverse x for all x belongs to closed interval of minus 1 comma plus 1, and theta must belongs to closed interval of minus pi by 2 comma plus pi by 2. So therefore here sin 30 degrees, 30 is belongs to this interval, 30 means theta equal to 30 degrees. It is belongs to closed interval of minus 90 comma plus 90 degrees. Next, that to be x equal to 1 by 2, it is in closed interval of minus 1 comma plus 1. So we can write like that. So sin 30 equal to 1 by 2 means what? This 30 degrees, this 30 degrees equal to sin inverse of 1 by 2. Thus, this is sin inverse of 1 by 2 can be 30 degrees. So therefore, in radians it is minus pi by 6 over. So answer is minus pi by 6. Next, second question, cosecant inverse of 4. You come here. Second question. Look at the bird. Cosecant inverse of. Actually, formula cosecant inverse of minus x equal to, first it is cosecant inverse of x. So for all x belongs to capital R minus open interval of minus 1 comma 1. Another formula is there. Cosecant inverse x is equal to sin inverse of it is 1 by x. This is the second fundamental formula. So this is also true for all its domain. It is true in its domain. Cosecant inverse x domain. Cosecant x domain, cosecant inverse x domain means capital R minus open interval of minus 1 comma 1. So here already 0, you can ask me, sir, if x equal to 0, then it is not defined. Correct. But 0 is already deleted. So we need not write x not equal to 0. Right. So these are two basic formulae. You come to the question. Cosecant. So cosecant inverse of minus root 2, that is equal to, using this formula, minus cosecant inverse of root 2. Cosecant inverse of root 2, that is equal to minus, next using this formula. Actually it is root 2 divided by 1. Then it is sine inverse of 1 by root 2. Sine inverse of 1 by root 2. That is equal to minus. Now we think of sine inverse of 1 by root 2. Sine inverse of 1 by root 2. 1 minute. Here actually sine 45 degrees means sine pi by 4 equal to 1 by root 2. Remember this pi by 4 is belongs to closed interval of minus pi by 2 comma plus pi by 2. These are the main basic points. And this 1 by root 2. 1 by root 2 means 1 by root 2 means root 2 value suppose 1.4. So approximate equal to 10 by 14. Approximate equal to 0.7 something. Of course, it is belongs to closed interval of minus 1 comma 1. So I am telling that it is also belongs to closed interval of minus 1 comma 1. So in this case only this pi by 4 can be sine inverse of 1 by root 2. 1 by root 2. So therefore this value is pi by 4. So answer is therefore cosecant inverse of minus root 2, that is equal to minus pi by 4. Minus pi by 4. Next, third one, cos inverse of. Actually the standard formula cos inverse of minus x equal to pi minus cos inverse x comma x belongs to closed interval of 0 comma pi. 0 comma pi. So therefore our question is what is cos inverse of minus 1 by 2, or what is principal value of already I said principal value means principal branch. Sine principal branch closed interval of minus pi by 2 comma plus pi by 2. Cos principal branch closed interval of 0 comma pi. That's why we are discussing in this interval only. So this is pi minus cos inverse of 1 by 2. So pi minus like that. Here cos 60 degrees, cos 60 degrees equal to 1 by 2. So this 60 degrees is belongs to closed interval of 0 comma pi. Means what? We are discussing in bijective area only. In bijective area only it can be expressed like that. So it will be belongs to closed interval of minus 1 comma 1. So then only this pi by 3 radians equal to cos inverse of 1 by 2. Otherwise it is not possible. So cos inverse of 1 by 2 is pi by 3. So on simplification, 3 pi minus pi whole by 3, that is equal to 2 pi by 3. Answer is 2 pi by 3. Pi by 3 means 60. 60 into 2, 120. 120 it is belongs to its bijective area 0 comma pi. Therefore this is called principal value. Otherwise it is not principal value. Next, in second question also, this value is belongs to closed interval of minus pi by 2 comma plus pi by 2. That's why it is called principal value. You come here. In the first question also, minus 30 degrees, it is also belongs to closed interval of minus pi by 2 comma plus pi by 2 because it is sine inverse. That's why it is called principal value. These are the basic formula, applications of basic formula. Next, prove that 2 tan inverse of 1 by 2 plus tan inverse of 1 by 7 equal to, again in terms of tan inverse of 31 divided by 17. Here we have one different formula. 2 tan inverse x is equal to tan inverse of 2x divided by 1 minus x square for all x belongs to open interval of minus 1 comma 1, that is minus 1 less than x less than 1, and that is equal to minus pi plus tan inverse of, this is an important formula, 2x divided by 1 minus x square if x less than minus 1, means that is what, this is 0, it is 1, this one is minus 1. In this area, this is tan inverse of something. Next, out of means in this area, this is second formula. Next, greater than 1 means this area, it is pi plus tan inverse of 2x divided by 1 minus x square. This is a most important formula. Okay, you come to left hand side value 2 tan inverse LHS is equal to 2 tan inverse of 1 by 2 plus tan inverse of 1 by 7, that is equal to, it is tan inverse x equal to 1 by 2. 1 by 2 means it is belongs to open interval of minus 1 comma 1, this area. That's why we are using this formula, direct formula, tan inverse of 2x by 1 minus x square means 1 by 4 plus tan inverse of 1 by 7. So that equal to tan inverse of 2 to cancel, 1 divided by 4, 3 by 4. 3 by 4 means 4 by 3 plus tan inverse of 1 by 7. So therefore, clearly it is in the form of tan inverse of x, tan inverse of x plus tan inverse of y. Actually, here x into y is what? X into y equal to 4x value 4 by 3, y value 1 by 7. So 4 by 21. It is less than 1. Therefore, xy less than 1, comma, x is positive and y is also positive. How? X equal to 4 by 3 positive, y equal to 1 by 3 positive. So this is the case xy less than 1, comma, x comma y both are positive. In such a case, tan inverse of x plus tan inverse of y equal to tan inverse of x plus y divided by 1 minus xy. So that is equal to tan inverse of x plus y 4 by 3 plus 1 by 7 divided by 1 minus 4 by 3 into 1 by 7. So that equal to, it is tan inverse of, actually you can simplify it, definitely we are getting, it is 31 divided by 17. You can verify the simplification, hence the problem. This is the procedure.